we're going to start a study now into transformations. Now, to help you understand what a transformation is, consider this little smiley down here. Now notice I could move this over to the left or to the right, to the left, up, down, diagonally. And that's a type of a transformation. That's called a translation. Now I could also, if I wanted to, I could reflect it. So look at this. I'm going to copy it, paste it, and put it right here. Now what we have is a reflection, okay? And we say it's a reflection in this line. It's like a mirror image. We could also do this. We could make it go around in circles like this, and that is a rotation. So the point is, we've got lots of different translations, or transformations, I should say. And up here in this little box, I've got, pictures of different kinds, 3 different kinds. What we're going to focus on right now is the reflection. Now, let's just look at this right here. The reflection in a line. Consider this blue F over here, this one right here. This is called, in this particular transformation, this is called the pre-image. Now, it's being reflected in this line. This is called the line of reflection. And what you get is this F over here. It's like the mirror image. Okay? So it's like when you're looking in the mirror, you're the pre-image, and then the image is staring back at you. So these are some terms. We've got the pre-image right here. We've got the line of reflection. Now, notice this, that if this line, let me call it line L. If line L is the line of reflection, notice what that means. If you find any point on this F here and take note of the distance to the line of reflection, the corresponding point over here is going to be the same distance. Okay? That point, go over here, and this point, same distance. Okay? And notice something else about these reflections, this reflection. The shape of what's being reflected does not actually change. In other words, this length is the same as this length over here, you can see. Every angle is the same as its corresponding angle. So what you get is what we call a rigid shift, in that the shape, the size of what's being transformed does not change, just the location. So we call this a rigid shift, a rigid transformation. A rigid transformation. Now, you can get fancier and call it an isometry. For some reason, I have trouble with that word. Isometry. Isometry. Okay. But it's a rigid transformation. I think rigid transformation is a little more descriptive. Okay, so let's look at this. We've got this triangle, ABC. Okay, we've got ABC. And we're going to transform, we're going to reflect that to get this triangle that has the points A prime, B prime, and C prime. That's how we're going to denote the transformed triangle. Okay, so let's see how this would go. Let's see how we would transform something. Okay, so we have the pre-image here. And I'm going to just look at each point. Now notice this C. This C, that point C, is at -1, 1. Yeah, that's that point. Notice, if you look at the distance to the point line of reflection, it's 1 unit. So if we want to get C prime, we're going to go 1 unit to the right. So it should be 1, 1. See? So just like it's 1 unit to the left to get to the C, it's going to be 1 unit to the right to get to the C prime. So we get 1, 1. Now we can do the same thing for B. If you look at B, it's at, let's see here, 1, 2, 3. So it's a 3, and then 1, 2, 3, 4. So we got this point 3, 4. And then we want to get to B prime. Well, it's 1, 2, 3 units over. So we're going to go 3 units to the right. 3 units to the left to get to B, 3 units to the right to get to B prime. So this, oh, I said 3. This is -3. Sorry about that. This one's going to be 3, 4. Yeah, I messed up there. Sorry about that. And we would do the same thing for A. So A, let's see what point that is. Just for good measure here, we've got 1, 2, 3, 4, -4, and 1. And we translate that over to A prime, and we get +4, 1. See, 1, 2, 3, 4. Yeah, there we go. So you can see that what we did here was we reflected the triangle ABC in the y-axis. So we reflect it in the y-axis. Okay, there we go. Okay, so let's look at this now. Now we've got a triangle ABC, and let's reflect that in the line x equals 5. So let's just think about how we would do that. Now, so we've got this triangle ABC, and we've got the translation, or the reflection here, A prime, B prime, and C prime. Let's see what happens. Okay, so I'll just do in order. I'll go A. The A point is, let's see here, what we've got 2, 2. Okay, that's this point A. It's 2, 2. Now let's see what the A prime would be. Well, notice now remember, we're concerned about the line of reflection here. Okay, so let's see how far A is from the line of reflection. It's 1, 2, 3. So we go to the left 3. No, notice 5 minus 3 is 2. So now we're going to go 5 plus 3 and get 8. The y doesn't change. Okay, so let's go over here. We got 1, 2, 3, and there is our A prime. Let me take out part of this. Okay, so this right here is our A prime. A prime. Now, as far as B goes, let's look at this. We got B is 4 and 2. You look at that. And then B prime then, look, we go only 1 over. So B prime is going to be right there. And it's going to be 6, 2. See? So we just about got it. Now, as far as C goes, let's see here. C is the point, let's see here, 1, 2, 3. So it's got a x-coordinate of 3, and then we go up 1, 2, 3, 4, 5. 3, 5. And C prime then is going to be, notice, to get over here, we go 2 units over. So to get to the new C, we're going to go 2 units over. And we're going to have 7, 5. Now let's see if that works. We go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yeah, there it goes. And there's our transformation. Now notice, we were reflecting this in the line x equals 5. It's a vertical line, so notice all the x's changed. The y's didn't change at all. If you just dig this, the y's are all the same. Okay? So what changed were the x's. Now, let's do this. Let's change this up a bit. And let's take this triangle ABC. And instead of reflecting it in the x equals 5, let's reflect it in the x-axis. So notice we've got the same points. We've got 2, 2, 4, 2, 3, 5. Okay. Now our concern is this. So I want A. Okay. So I need to go 2 units. From A to the line of reflection is 2 units, so I'm going to go 2 units down here. Okay, so there is my A prime. Now B, same thing. 2 units, 2 units. There is my B prime. And then C, let's see what we got here. We got 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. There's my C prime. Now you notice this time, only the Y's changed. The X's were all the same. That's how we reflect it. Now, so notice the Y's changed here. And you could compute those points if you want it and take note, but I think you get the idea here. Now, let's look at reflecting in the y-axis. Now, notice this is another vertical line, and look what happens. We've got A, B, C. Now, look, to get A, we're going to go over 2 units this way, so I go 2 units this way. There's my A prime right there, A prime. As far as B goes, we go 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 and get my B prime. And then C, we go 1, 2, 3. So 1, 2, 3. There's my C prime. There. And there we have reflected in the y-axis. Yeah. So notice we were reflecting, and in reflecting you have the pre-image, which is, that's what you start with. And then you have the line of reflection, this right here. Now, I want to talk about something, a different line, a line of symmetry. Let's suppose you have a figure like this one right here. Okay, this one right here. And what we want to talk about is the symmetry in that figure. And we want to talk about a line of symmetry. In other words, is there a line that I could make so that I could fold, it's a folding point, so that I could crease this image and fold it where it would lay exactly on top of itself. Let me show you. Let's think about this line right here. Now, this is a line of symmetry because dig this. If you go from this line over to any point, it's the same if you go from left to right. Okay? If you look at all these, look at all these little things here. This is symmetrical. It's symmetrical about this line L. This is a line of symmetry. And for this shape, I believe that's the only line of symmetry we've got. Now, some things have more lines of symmetry. Okay, so this has one line of symmetry. Think about a square. And I say, okay, I want to find a place where I can just fold this on top of itself. Well, right here's one. That's a line. I'll call that line 1. Okay, now we got another one right here for a square, right? Look at that. I'll call that line 2. So there's 2 lines. I could fold it left to right or up to down, Each one of these are places we could fold, but wait a minute, there's more. Look, I could do this. I could, right over here. There's one. I'll call that line 3. Okay, so there's line 3. And I believe there's one more. Look at this. And that's line 4. Okay, so you can see different shapes will have different lines of symmetry. Some of them, some will have a lot more than 4. Look at this. Now, here I've got 3 hexagons. 3 hexagons. And you notice this first hexagon, and you can count the sides. 1, 2, 3, 4, 5, 6. 6 sides. You notice that this one has one line of symmetry. There's only one place there where you could draw a line where the thing will fold on top of itself. Now let's look at another hexagon. This one right here. There are 4 lines of symmetry here. Okay, 4 places where it will fold exactly on itself. I mean, I said 4, 2. I meant 2. 2. There's 1 here and 2 here. Okay, 2 lines of symmetry. You can fold it here, or you can fold it here. I think I said 4 because I was looking at these things. Okay, 2 lines of symmetry. Now, so this is, now let's move on to another one. Let's look at this one. Okay. This one has 6 lines of symmetry. Okay. So you can see this one. You can see this one. There's 2. So here's L1, L2, L3, L4, no particular order, L5, and L6. Yeah. So depending on the figure, you can have different lines of symmetry, different numbers of lines of symmetry.